Okay, guys, we are going to continue our review of chapter 11. We're moving now to section 2 problems. We're going to find these on page 394, and the first problem we're going to work with is problem number 72. And you can see here that I've already written the balanced equation that the question provided, so you need to include that on your work right now as well. So this question says, there are a lot of words here, but if you actually read some of the questions that we're working with right now, they actually help us understand how chemistry is used in a lot of the everyday processes of our lives and things that we encounter. So I think that's really kind of cool. So this says that photographic film contains silver bromide in a gelatin. Once exposed, some of the silver bromide decomposes, producing fine grains of silver. The unexposed silver bromide is removed by treating the film with sodium thiosulfate. Soluble sodium silver thiosulfate is produced, right? So they're asking us here to determine the mass of sodium silver thiosulfate if we remove 0.275 grams of this. Now, the wording of this question says removed. That's because when that much is removed, when we're talking about, if we read that process, it says when a certain amount is removed, then we can determine how much of this is produced. So that's why the language of that is removed instead of used here. It just fits the process, okay? So now that we have our balanced equation, and this is long. This thiosulfate, that's a polyatomic ion. And that was on your list. It's not one that we work with very much. But here we go. So let's put our data in. So this says that we are removing 0.275 grams of the silver bromide, and the question is, how many grams of this will be produced? So we can see from the data that's been given to us, this is not a limiting reactant question because we only have one piece of data given to us. We do not have to determine anything between these two products. So this means that we are going to be able to just move straight to our stoichiometry path and go from grams to moles. Now, if you're looking at examples in your textbook is going to go from grams to moles and write an equal sign and find an answer right here. And then you use that answer to use the balanced equation ratios and come up with an answer right here. You write another equal sign. Then you use this piece of information to use the molar mass and then solve for grams. So you do 3 math problems. You solve, and you solve. And what I'm asking you to consider in your solving is to consider this really one question where we're given this piece of information and we're going to find this answer. We are doing exactly the same steps. We just aren't writing this answer down. We're letting it hang out in our calculator. We aren't writing this number down, or at least in my samples. But here's the thing, guys. To solve this part and write an answer is correct. To solve this part and write an answer is correct. And then use this information to go to here is correct. That will never be marked wrong on your work. However, if you write an answer and write an answer and write an answer, then 3 times you have to round and use the appropriate sig figs. So you have more work to do, in my opinion. But that's just me. So that's why we keep using our little, and this graphic is actually in your textbook. It's just it's more complicated, but this graphic is in your textbook. So you can compare it and see how that works out. Okay, so let's get back to this question. I just wanted to help you understand what we're doing. I do not want to write with red. Here we go. Here's my black marker. There we go. All right, so The stoichiometry here then starts with our given piece of information. So here would be a good place for you. Pause the video, you work it out and try to solve this question, and then come back and see how we're doing, okay? So you know what I'm going to do first? Since I need the molar mass of this and I need the molar mass of this, I'm going to do that first before I solve the question, okay? So let's find the molar mass. So AgBr. The molar mass of that is 107.868, and bromine is 79.904. So when I add that up, the molar mass that I'm going to need is 187.772 grams per mole. All right. Now let's find the molar mass of sodium silver thiocyanate. All right. So this means that we're going to have, for sodium, we have 3 sodium, so it's 22.990. And if we multiply that, that gets us 68.97 grams. We have 1 silver, so that's going to get us 107.868. Oh, silver. Sorry, left out the G. And then we have 4 sulfur. So that's going to be 4 times 32.066. So that equals 128.264 grams. And then we have 2 times 3 is 6 oxygens. So we're going to have 6 oxygens. That'll be 6 times 16, and that is 96 grams for the oxygen. Then we're going to add all of that up. So that's 401.102 grams. And since I only have 2 decimal places here and 2 decimal places here, I will just scratch that number. And so we'll use this when we get into our stoichiometry, okay? All right, so now we can solve the problem. Now we have those molar masses, so we can use those. We could have done those later, but that will get us started. So our stoichiometry starts with 275 grams of AgBr, and we're going to convert that to moles by saying that 1 mole of AgBr has a mass of 187.772 grams. And the grams will cancel, and we're going to move on, right? The next step is the balanced equation ratio. This is a large molecule. I'm going to do something that I don't normally do to save space, which is, this is 1 mole to 1 mole. Please forgive me, 1 mole to 1 mole. I'm just doing that to save space. I would normally put, right, this is AgBr2. This is the sodium silver thiocyanate. 1 to 1 is what we have there. And then we're going to do our, let's look back at this. So we've done grams to moles right here, balanced equation ratio. Now we're doing this last leg, which is 1 mole on the bottom, 1 mole on the bottom, and then the molar mass on the top. So 401.10 grams of the sodium thiocyanate. Now, once I have all of that written out, I can pick up my calculator and solve this problem. So let's do that together right now. And you try this as well. So it starts with, I'm going to, move that. So 0.275 divided by, times 1 divided by 187.772 times 1 divided by 1. Obviously, those are identifiers, but just to keep us doing the step, and then times 401.1. Oh, I lost something in my calculator, so I'm going to run it again. 0.275. Sometimes that happens, right? Divided by 187.772 times 401.1 equals, and I know you can't see it on there. I'm going to put it right up there. So the answer here, my calculator has a lot of digits. I look back over here. I can have 3 sig figs. So the first 0 is a placeholder. 5, 8, and then I look at the 7. The 4 does not make that round up. So 0.587 grams of sodium silver thiosulfate. That is the answer to the question. Now, your task in this review section is to do number 70 and number 71. This was number 72. You do these 2 questions as a part of Mondays, Wednesdays, or Tuesdays, whatever day you're getting this, Monday or Tuesday. That's the first part of your first homework assignment. So these are 2 more questions. So far, you have 4 questions to do. And you got another video coming your way.